Hello everyone, welcome back to my channel Learn Math with Priya. In this video, we are going to discuss the first chapter of grade 10, which is real numbers. So, what are real numbers? Any idea? To understand it much better, let's dive into our video. Let's talk about real number system. First, we will see what are natural numbers. Natural numbers are also known as counting numbers. It helps us to count. If, for example, 3 pens, 4 tables, so 3 and 4 are natural numbers and it helps us to count, isn't it? So, natural number starts from 1 and it goes on till infinity. And then in grade 6, we have learnt about whole number system. So, what are whole numbers? Along with natural number, if I add 0 to it, then it is called whole number system. It starts from 0, 1, 2, 3, and so on till infinity. So you can see here, natural number is a subset of whole number, or else we can say whole number contains all the natural numbers. And next we have learnt integers, right? Positive number, negative number, and 0 we call it as integers. For example, 4 is a positive integer, minus 3 is a negative integer, and 0 is 0, right? So integer contains all the whole numbers. So you know whole number contains all the natural numbers, right? Okay. And in grade 8, we learnt about rational numbers. So, rational number contains fractions and decimals. Okay, any number which can be expressed in terms of p by q, where q shouldn't be 0, right? The denominator shouldn't be 0, and p and q, the numerator and denominator, can be integers as well. So, this we call it as rational numbers. In terms of decimals, we can call rational number as recurring decimals or terminating decimals. So any decimal which terminates or recurring, we call it as rational numbers. Okay, so all the fractions and decimals belongs to this rational number system. And then we have just introduced in grade 9 about irrational numbers, right? So what are irrational numbers? Any number which cannot be expressed in terms of p by q, or the decimals which neither terminates non-recurring, we call it as irrational numbers, isn't it? For example, root 2, root 3, this cannot be expressed in terms of p by q, right? So this we call it as irrational numbers. So the real number system is complete with rational numbers and irrational numbers. Okay, so real number is complete with rational numbers and irrational numbers. So you know that all natural whole numbers, integers are included within rational numbers, and irrational number is a separate. So together rational and irrational we call it as real numbers. So real numbers system is complete with rational numbers and irrational numbers. Hope you're clear with real number system. With this concept, we are going to learn the fundamental theorem of arithmetic. So before learning fundamental theorem of arithmetic, what are the prior knowledge required to understand that theorem? Let's see. Before moving to fundamental theorem of arithmetic, we should understand what are prime numbers and composite numbers. So what are prime numbers? Prime number has two factors, isn't it? For example, if I say a number 7, 7 will be divisible by 1 and by 7 and leaves a remainder 0. So it has only two factors, isn't it? So prime number has only two factors, the number 1 and the number itself. So whatever number I'm taking, that number itself and the number 1 is going to be the factor of the number. For example, say like 11. 11 will be divisible by 11, 1 and leaves a remainder 0, as well as divisible by 11 and leaves a remainder 0. And none other multiplication table will contain the number 11, isn't it? So it has only two factors, hence we call it as prime numbers. Then what are composite numbers? Composite number has more than two factors. For example, 4. So if I take a number 4, so what are the factors for 4? It will divisible by 1, it will be divisible by 2, as well as it will be divisible by 4 and leaves a remainder 0, isn't it? So I can understand here I have three factors, 1, 2 and 4. Let's take another example, 15. So here 15 will be divisible by 1, 15 will be divisible by 3 and leaves a remainder 0, 15 will be divisible by 5 and leaves a remainder 0, and 15 will also be divisible by 15 itself and leaves a remainder 0. So it has more than 2 factors, right? Because 15 has 4 factors. So always remember, whenever any number which has only 2 factors, the number 1 and the number itself, we can call it as prime number. If it has more than 2 factor, then we will call it as composite numbers. So this basic understanding is very important to do fundamental theorem of arithmetic. Let's start with the first theorem, which is fundamental theorem of arithmetic. Every composite number can be expressed or factorized as a product of prime, and this factorization is unique apart from the order in which the prime factor occur. So what they are saying, every composite number can be expressed as a product of prime. Can we see that? For example, if I take a number 6, 6 can be expressed as 2 times 3. Okay, I know 6 is a composite number, and I'm expressing as product of prime numbers, right? 2 and 3 are prime numbers, and it is expressed as a product of prime. Okay, for example, if I take 210, so if you don't know how to write the product of prime, you always learn the ladder method to do prime factorization, isn't it? Please go for it. I know 210 is a even number, so it will be divisible by 2. So if it is 1 not 5, right? And again it can be divisible by 5. So 5 times 2 is 10, 5 times 1 is 5. It can be divisible by 7 or 3, so 3 times 7, right? So 210 is expressed as 2 times 5 times 3 times 7, and I have to choose only the prime number to divide it. So the first point is very clear. Every composite number can be expressed as a product of primes, isn't it? So see, 6 is expressed as 2 times 3, and 210 is expressed as 2 times 5 times 3 times 7. And each composite number can be expressed in only one way in terms of product of prime number, isn't it? They are different from each other, right? For example, if I want to write the product of prime of 8, it is 2 times 2 times 2. So 3 2's are multiplied by itself to get 8, which is unique way of representing the product of prime for 8. Similarly, 15 can be expressed as 3 times 5. Any other number cannot be expressed only with the primes of 3 and 5. Only 3 and 5 will give you the number 15, isn't it? Hence, the factorization is unique. Okay, and what they are saying, the next point, apart from the order in which the prime factor occurs, so it is irrespective of the order. For example, 210 is also written as 3 times 5 times 2 times 7. Suppose if I just taken the order in other way, for example 3 first and then 2, I'm changing the order, but still it gives me the composite number 210 when you multiply all the prime, right? So irrespective of the order, each composite number can be uniquely expressed as a product of primes. Do you understand? So we can conclude, for any composite number there is one and only one way to write it as a product of primes. Got it? So did you understand the fundamental theorem of arithmetic? Let's meet in our next video for the continuation of the topic real numbers. Practice all the basic concepts. Thank you.